Can you hear me, class?
Yes, ma'am.
Okay. So we're starting in 2 minutes. If there is any issue related to this approval or anything of your friends, do tell me. We'll sort out that issue also. Good morning, students. Today we'll do what we have started in the previous lecture. We'll complete that topic, that is project management. In that we will do project scheduling, and today we'll study also the cost effective models, like cost estimation models. If we want to estimate the cost of a project beforehand, what we can do, how we can estimate the cost, such things we will discuss today in this lecture. I'm sharing the PPT, as well as I will be discussing on the board and telling you people. And the numeric in this portion will cover numerical parts too. So starting with software project scheduling and the cost model. cost estimation model that we are going to discuss today is COCOMO model. I hope everybody can easily see the board here. Is that okay to everybody?
Yes, ma'am.
Okay. So, in the last lecture, we have discussed project scheduling, software project management, and project scheduling. So, first of all, what is project scheduling? Project scheduling in a project refers to roadmap of all activities to be done with a specified order and within time slot allotted to each activity. Project managers tend to define various tasks and project milestones and then arrange them in keeping in mind various factors. They look for tasks like that lie in critical path in the schedule which are necessary to complete in specific manner and strictly within the time allocated. So project scheduling is all about doing things critically in that specified time. Arrangement of tasks which lie outside of critical path are less likely to impact overall schedule of the project. So in project scheduling, a project is necessary to have a breakdown of the project task into smaller manageable forms, find out various tasks and correlate them, estimate time frame required for each task, divide the time into work units, assign adequate number of work units for each task, calculate the total time required for the project from start to finish for scheduling a project. I'm repeating, break down the project. If you have any project and you want to make, if you have an idea and you want to make a project on it, first break down the project into tasks, smaller manageable forms, and then correlate them. I'm repeating, correlate them. Estimate the time frame required for each task. Like I have given you one video related to university management system in the lab part. So if you are developing a project related to university management system, you need to divide into registration, in the examination section or course section. So such kind of task. And after that, what you need to do is to estimate the time frame for each activity. How much you will take for requirement analysis, how much you will take for design, how much you will take for coding, such kind of activities. Divide the time into work units, assign adequate number of work unit for each task, calculate the total time required for project from start to finish. So this is the estimate time. From the estimate time, we mean that we are estimating the time beforehand, before making the project. We need to estimate the time so that only we can uh, uh, give information to the stakeholders who are with this project, that this much time it will require to develop this project. The next process, how to schedule or sequence activities. We have activities with us and we have divided the task and activities. Now next phase is how to schedule and sequence the activity. The next process involves taking the activities and milestone and starting to sequence into how the work will be performed. The result will be, if you are developing anything, the result will be you have a sequence of activities like requirement analysis, feasibility study, design, coding, testing, implementation. These are the common activities that every project has. uh, what you can do is you have to make a network diagram for that. If you are doing requirement analysis, what you want to do, you want that requirement analysis activity should be parallel with the feasibility study, then it will be like that. But if you want that it should be after the feasibility, should it be after the requirement analysis, you can have it like this. So feasibility will be only after you are done with the requirement analysis. So in this way you can draw the network of all those activities. You can see on your PPT screen, they have drawn a network diagram here. This is not a PERT chart. Remember one thing, PERT chart is project evaluation and review technique. This is only a network of all the activities, network diagram of all the activities. They have just named the two activities, start and you can see on the slide here, start and end. So what is PERT? PERT is a method of analyzing the task involved in completing a given project, especially the time needed to complete each task. It is analyzing the task involved completing a given project and the time to find the minimum time needed to complete a total project. PERT was developed primarily to simplify the planning and scheduling of large and complex projects. So we have PERT here and CPM. PERT was developed by US Navy for the planning and control of the Polaris missile program. And this CPM, critical path method calculation, that was developed by DuPont to solve the project scheduling problems. The emphasis of the PERT was on completing on program in the shortest possible time. The emphasis for emphasizes on CPM, that this critical path method was to find on the trade-off between the cost and project and its overall completion time. I hope everybody must know everybody is aware of what is trade-off. PERT is a work model devised to complete the project work in in time. It analyzes the actual work time required to complete a task. PERT is very famous project model that has found its use in various professions, including nursing. This model helps in judging the time required in completing an activity. Nurse administrators can use this model to delegate and assign the work schedule and to the nurses in a hospital. It not only evidences the cost effectiveness of nursing care, but also has great impact on reducing the expenditure by a patient. So as it will calculate the time required, so the effort will be calculated. This model helps to reduce the patient hospital stay by judging beforehand the actual care time, manpower required, money and material required. Therefore, following this model helps to prevent waste of time, money, material, benefiting the patient and the hospital management. The part consists of the finished product or a service desired, the total time and budget needed to complete the project or program, the starting date and completion date, the sequence of steps or activities, the estimated time and cost of each step or activity, is a model for project management designed to analyze and represent the task involved in completing a given project. Components of PERT model. So there are different components of PERT model. PERT, I am again repeating, this is project evaluation and review technique. So it will calculate the time. Which time? Estimated time. How it will be calculating the estimated time? The components of the PERT model include predecessor events and successor events. Every activity consumes time and needs adequate resources such as manpower, materials, space, and machinery to change or move one event to the other. Predecessor events, it is an event that precedes some other event. It can be a single or multiple. And successor event, it is an event that immediately follows some other events. It can have single or multiple successor events. Like if I'm saying A is here and B is here and C is here, and the sequence of activities are such like that. So A predecessor is C and A successor is B. So these are the activities. So A's successor activities will be B and A's predecessor activity will be C. It may be one, it may be more than one. So components of PERT model consist of predecessor events and successor events I have discussed. Next is the time. The time that a PERT evaluation, PERT, project evaluation and review technique model consists of optimistic time, pessimistic time, most likely time. Now, what is optimistic time? It is the minimum possible time required to complete the task, anticipating that every event has occurred better than usually expected. I am again repeating. It is a minimum amount of time, possible time required to complete the task, anticipating that every event occurred better than usually expected. Gagandeep, is there any issue?
Ma'am, please approve the registration of Amisha. Ma'am, she has a loan case.
Okay.
Yes, ma'am. Ma'am, and Kamlesh भी है उसका भी.
Kamlesh is, I think, late in the class.
Yes, ma'am. Yes, ma'am.
I will not permit anybody in the who is coming late in the class.
Yes, ma'am. Thank you, ma'am.
It is an issue for everybody that will come late and teacher will be busy in that. In So you can see how much time wastage is there for approving those people who are just joining. It's better you should join, you should send your request beforehand. There is nobody in the list here. Nobody has sent any request for registration. Amisha as well as anybody else. He
शायद कल की होगी इसने.
has not sent any registration request.
Yes, ma'am.
So optimistic time, it is the minimum possible time. I am again repeating it is, I am repeating for the third time. It is a time, minimum possible time required to complete the task, anticipating that every event has occurred better than usually expected. So we have three times: optimistic time, pessimistic time, and most likely time. The pessimistic time means the maximum possible time required to complete the given task, expecting the assuming everything goes wrong except the main catastrophes. So most likely time, the actual and the best time required to complete the task, assuming everything goes in a usual way. So what we need to do is we need to calculate the optimistic time for every project that we are going to develop. We need to calculate the pessimistic time when we need to calculate the most likely time. And from these time, what we need to calculate is what we can calculate the expected time or the very best time, and that is given by TH, the accurate or the actual time required to complete the task. It is the most reliable and valid time estimated to complete a task. It can be calculated using the following relation. The relation is shown here on the screen. I'll write here also. If you are not able to see the slide, you can see TH is the estimated time. And we have three times. Which times? Optimistic, pessimistic, and most likely. Optimistic, pessimistic, and most likely. So we can have formula like this: optimistic plus 4 times most likely minus pessimistic divided by 6. This will be the time, expected time. Suppose the optimistic time is 5 minutes and this pessimistic most likely time is this most likely time is 10 minutes and this pessimistic time is 15 minutes. So with that we can calculate 5 plus 4 into 10 minus the pessimistic has 15 minutes and divided by 6. So that will be comes out to be the time, that expected time or the very best time we can calculate. Always remember one thing: this is the expected time that a project will require, and this in this way we can calculate the project evaluation and review technique methodology by using this method. So project evaluation and review technique is what? It is a graphical representation. Basically, it is a chart that represents the activities and calculates the optimistic, pessimistic, and most likely time. And also it has the option to calculate the critical path of task that has to be finished in time. So this chart, this is a chart here you can see on the screen. We have a start, purchase time, purchase edging, mark utilities, dig holes, plant trees, plant flowers. These are some of the activities they had and they have numbered the activities. From the numbering of activities, we mean that from the start it will move towards one. It may go to one may go to three or two. In such way, they have sequenced the activity, and you can also draw the per chart for your problem. This is the way you can see from the start. Task 1 will take 3 days, and from the start task 2 will take 2 days. So you can imagine this task 1 and 2, this task 1 and task 2 are running in parallel. From task 1 output and task 2 output will become the task 3 input. From the task 3 and from the task 4, that is going directly, we are ending the project. So in this way we can have a calculation of the critical path. Steps involved in PERT planning process. PERT involves the following steps. Specific activities and milestone. We need to define the specific activities and milestone. Sequence of the activities. Drawing the network diagram. Estimating the time, that is optimistic, pessimistic, and most likely. Calculating the critical path. I will tell you how to calculate the critical path in the next presentation as well as on the board, and update the PERT chart. So these are the steps for that involve the PERT planning process. First of all, identify the specific activities and milestone. It is helpful to list the task in the form of a table. Determine the proper sequence of activities. We need to have a proper sequence of activities. If the activities are not in sequence, or we are doing a shuffled way of taking activities every time, it will not yield a critical path of those activities. Since the activity sequence is evident from some task, as we are developing the project, we know what needs to be done before a particular activity. So the things or the sequence is evident. Other tasks may require more analysis to determine the exact order in which they must be. But you need to determine the exact order in which they need to be performed. Construct the network diagram. So whenever we are developing anything, we need to construct the network diagram. This is simple optimistic and pessimistic way of calculating the things, but we can have network diagram of activities. A network diagram can be drawn showing the sequence of the serial and parallel activities. You need to define which activities are in sequence and which activities will be in parallel. So that should be properly defined. The arrows represent the relation between the activities. We need to define the arrows that define the relation between activities. Software packages simplify this task by automatically converting tabular activity information to a network diagram. There are so many software that convert a tabular means in the table form of activities like this: E3, 4, 5, 6, or we can have here further, there may be a predecessor A, C, D, E. So in this way, this tabular form can be converted into this network. We have that software too in the software engineering paradigm. We are done with estimating the time required for each activity. Weeks. We need to estimate the time. This is the time: 3 weeks, 4 weeks. A is taking 3 weeks, C is taking 4 weeks, D is taking 5 weeks, E is taking 6 weeks. And calculate the optimistic time, most likely time, pessimistic time, and calculate the estimated time. I told you how to calculate the estimated time. Now, what we need to do next? After determining the estimated time using optimistic, most likely, and pessimistic, we have calculated the expected time. Other way of calculating the critical, we need to calculate the critical path. That path we need to follow so that it should require minimum possible way of calculation. That means the critical path is basically the path that is efficient and has a longest path in the project. Critical path determines the total calendar time required for the project. The total calendar time required to complete the project. Suppose this is start and this is finish. From we have two paths. One is this path, another is this path. The critical path is the longest possible, the maximum possible path that needs to be followed for doing any project. That is the critical path. Critical path determines the total calendar time required to complete the project. Methods to draw network diagram. In past, the president's diagramming method or diagramming method, ADM, and GERT method were commonly used. Today, most network diagrams are created using PDM, President's Diagramming Method. Types of dependency. As I already told you, there are mandatory dependencies, discretionary dependencies, and external dependencies. Now, what are these dependencies? Mandatory dependency is hard logic. The dependency, the mandatory dependency is inherent in the nature of the work being done or required by the contract. You must design before the construct. That is a mandatory dependency. You cannot move towards C until you have completed the B. This is mandatory dependency. Discretionary dependency means preferred or preferential soft logic. This dependency is determined by the project team. Discretionary dependencies can be changed if needed. So the dependency like B can only be done after C has completed is a kind of mandatory dependency. But discretionary dependency is the one in which we know that B can be done after D or before D. So that is a kind of discretionary kind of dependency. And external dependency means this dependency is based on the needs or desire of the party outside of the project. Some activities in the project are those activities that are dependent totally on the parties that are outside of the project. So we need to keep them aside because they are totally dependent on the outside parties, like government organizations or suppliers. I hope everybody is now aware of mandatory dependency, discretionary dependency, and third one is which dependency? It's external dependency. Now, leads and lags in the network diagram. Whenever we are drawing the network diagram, there are leads and lags. A lead may be added to start an activity before the predecessor activity is completed. For example, a coding might be able to start 5 days before the design is finished. We are designing anything. This is a design activity and this is the coding activity. Coding. So coding can start 5 days before design. Design is taking 10 days, suppose, and coding is taking 5 days. So when design is up to the 5 days, we can start doing coding. That is the we can say the way we can do the things, and that will be a lead. So 5 days lead. A lag is inserted waiting time between the activities. such as needing to wait 3 days after pouring concrete before construct the frame of the house. So lag is we are inserting some kind of waiting time between the two activities. That is called lag. I hope now everybody is clear with the lead and lag in the network diagram. So what is this network diagram? Every activity in the network diagram, suppose this is one activity, its name is A. Every activity in the network diagram A has some associated duration with it. Suppose it has three weeks. So this activity that has some associated duration itself with it is defined as with 3 weeks. An activity has 4 things in it. What is early start, early finish, late start, and late finish. What who is speaking? What we need to do is we need to calculate early start, early finish. From start and early finish, we can have latest start and latest finish of the activity. Is that clear to everybody? I hope now everybody can see on the screen that what is early start, early finish, latest start, latest finish. Earlier video was not shown to you, only the slide was running. Can you see on the board what is early start, early finish, latest start, latest finish?
Yes, ma'am.
Okay. So every activity you need to have early start, early finish, latest start, latest finish. You need to calculate these things: early start, early finish, latest start, latest finish. But how can we calculate this early start, early finish, latest start, and latest finish? And how can we calculate the critical path? So I am doing one numerical on the board. What you need to do is just follow the step. Suppose we have a project and a set of activities. This is activity A. It is taking 3 weeks. I am repeating. This is activity A. It is taking 3 weeks, and it has early start. Every activity needs to have early start, early finish, latest start, latest finish. For every activity, we need to calculate early start, early finish, latest start, latest finish. We have a project, any project, and it has some activities associated like A, B, C, D, E, F, G, and H. A, B, C, D, E, F, G, H. And we have these activity name, and this column define the predecessor. Predecessor means the activity is predecessor. Coming this activity is इसके पहले क्या आ रहा है? B activity के पहले कौन सी activity आ रही है? That means predecessor. And duration. And duration. So three headings are there: activity name, predecessor, and duration of a particular activity. Which activity? This activity. Suppose A has duration 3, but no activity is predecessor. This is the first activity, so there is no predecessor with the A. And suppose this B has a predecessor activity A with the duration 4. C activities has A duration 2. D activity has B with duration 5. E has duration 1 with the predecessor activity C. F has C with 2 duration as of that F activity. G has 2 predecessor activities B and E, and H has 2 predecessor activities F and G. This is the things that are the things that will be given to you in the paper in the tabular form, and they will ask you to calculate the early start, early finish, latest start, latest finish, and the flow time, critical path of project, the longest possible path, critical path of the project. So how can we calculate the critical path for project? How can we calculate the early start, early finish, latest start, latest finish in the diagram shown to you on the board for those activities? Before doing any one example on the board, I'll explain you on the PPT, and then I'll do this example with you. So first of all, what you need to do is,
मैम बोर्ड पूरा विजिबल नहीं है.
I hope now you can see the board. दिख रहा है अब?
नो मैम, थोड़ा सा लेफ्ट साइड से नहीं दिख रहा.
अभी भी नहीं?
नहीं मैम, अब तो बिल्कुल नहीं दिख रहा जितना पहले दिख रहा था.
अच्छा, पहले जितना दिख रहा, अब you can see the board or not?
थोड़ा सा लेफ्ट आओ बस, ठीक है.
Is it visible to everybody now?
यस मैम.
Okay, I'm coming towards the problem. See on the PPT, there is one same example given here. Like A is the first activity, so it doesn't have any preceding activity, and it is taking 3 weeks. And B is the activity that is preceded by A, and it is taking 3 weeks. In the C, we have A as preceding activity, it is taking 6 weeks, and D has B as preceding activity, it is taking 8 weeks. E has 2 preceding activities. मतलब क्या है? E is dependent upon 2 activities. Before that, E cannot move. Before that, E cannot move. C, D needs to be completed, and only then E can move. Then it is taking 4 weeks. So in this way, you will be given some examples, and you need to calculate the paths, critical path, duration of the critical path, float of activity B and C, network diagram. They will ask you draw the network diagram, find out all the paths and critical path. What is the duration of the critical path? What is the float of activity B and activity C? So how can we calculate these things? I'm coming toward that. First of all, what is critical path method? I told you earlier that this critical path method is a project modeling technique developed in the late 1950s by Morgan D. R. Walker and DuPont. And this critical path is the maximum path time that is required by a path to complete the project. It has least amount of float or slack time. What is a float time? A float time is the amount of time that an activity can be delayed without delaying the project. Suppose we have activity C and it is taking 3 weeks. That is a maximum time. A float is saying that it can be delayed without delaying the project. The maximum time we can delay particular activity without delaying the project. But हमें कैसे पता चलेगा कितना प्रोजेक्ट है? Suppose the whole project is taking 20 days. So we need to define for a particular activity we इतनी extend कर दो, पर 20 की जो date है, it will not be moving. It will be one date. A critical path usually has zero float, but may have negative float if the end task is constrained to an early finish date. If any of that task identified in the critical path is late, then the project will be late. अगर कोई activity late हो जाएगी, naturally the project will be late. I hope now everybody is clear with what is critical path. a critical path with the least amount of float and slack time. So we need to calculate the float time. What is float or slack time? A float time, I'm again repeating, a float time is the amount of time that an activity can be delayed without delaying the project. For an activity can be delayed. Suppose an activity is taking 3 days, it can be delayed to 5 days. But the total amount of days that a particular project will take, it will not be moved further. 3 से 5 तो होगी एक एक्टिविटी, और एक प्रोजेक्ट वो अगर कंप्लीट करने में 20 डेज लग रहे थे तो नहीं लगे. दैट इज व्हाट क्रिटिकल पाथ सेज. Some of the class students are not muted and causing nuisance in the class. Arish Khan. So, what are the steps for identifying the critical paths? Specify the activities, duration, and dependencies. I have specified the activities, duration, and dependency. You can see I have specified a activity with duration and dependency. A is not dependent on anything. In the board here, you can see on the board, in case of B, B is dependent on which activity? B is dependent on A with the duration 4 weeks. Next is C. C is dependent on A with the duration 2 weeks, and in the same way we have written here all the activities. Now draw the network diagram. What you need to do is this tabular form should be converted into a network diagram. I'll show you how can we convert that into a network diagram. I'm drawing the network diagram here on the board itself. So the network diagram for this activity will be A is the first activity. So A will be there. What is the another activity? So you can see the other activities are B and C. B and C are dependent on A. So though that means B and C will be running parallel. So it will be like that. B, C. I hope it is clear to everybody. Now D. D is only dependent upon B. So this activity will be here. D. E. E is dependent on C. Mind it, this lecture is being recorded. I'll send the instruction to the student who have done this. So this is C with this C activity. This C activity is dependent on A, and D is dependent upon B. This E is dependent upon C. So this is the E activity here. You can see. Now the F activity. F activity is also dependent on C. So that means there is another activity called F, and that is also dependent on C. So F and E are parallel, and they have a predecessor C here. After that, there is an activity called G that is dependent on D and E. So we can have this F here so that we can club these activities. F is dependent on E and G is dependent on E and D. There is another activity G. And this H activity, this is dependent on F and G. So it will be F, G, and we'll have H here. So this is the network diagram of a particular problem which have been given with the dependencies and durations. Is that clear to everybody till network diagram? Anchal. Yes.
Ma'am, in starting we said that the total time taken by the activity can be of 8 weeks.
I'm not able to hear you properly. Kindly speak loudly. Hello, Anchal. Can
Am
you
I
hear
audible?
me? Yeah, now you are audible.
Ma'am, in starting, we declared that the activity can be of 8 weeks. So, ma'am, that time period is for single activity or included all activities?
See, we are given what हमने शुरू से क्या पढ़ा अभी तक हमने ये पढ़ा we are given a project and we have divided that project into some tasks and those tasks are called activities like मैंने उसको requirement analysis and feasibility I am converting them into a form like A B C D ठीक है मैंने उन activities का नाम छोटा रख दिया A B C D is that
Yes,
clear to
ma'am.
everybody now what I am doing is I have calculated the expected time you people know how we can calculate the expected time from the most likely pessimistic and optimistic formula we can calculate the estimated time so this is what you are seeing on the screen in the third column 3 4 2 5 1 2 4 3 these are the expected time of those activities ये clear हुआ आपको
Yes, ma'am.
हाँ हमें पूरे प्रोजेक्ट की ड्यूरेशन अभी नहीं पता we are not with the how much time it will take to calculate for a particular project it will take to complete a particular project that we are calculating we are finding the path we need to follow there may be more than one path to complete a project एक प्रोजेक्ट को कंप्लीट करने के दो पाथ आप देख लो आपने ए से एच तक जाना है यू नीड टू गो फ्रॉम ए टू एच देयर आर टू पाथ्स वन इज ए बी डी एफ A B D G H three paths rather another is A C E G H and third one is A C F F so what we need to calculate is we need to calculate a critical path जो path longest भी हो and has least float and maximum duration जो project को complete करने में लगेगा हमने shortest नहीं लेना we need not to calculate the shortest path we need to calculate the right path the longest possible path क्योंकि उससे ज्यादा ना लगे टाइम हमने तो ऐसे मान के चलना मैक्सिमम इतना this much time this project can complete it should not take more than that we need to calculate that time इतना maximum इतना ले ले हमारा प्रोजेक्ट and after that there is no time limit मतलब और नहीं मिलेगा this is the critical path we need to find the critical path we are finding the critical path हमें अभी activities का time पता चला हमें प्रोजेक्ट का पाथ नहीं पता चला प्रोजेक्ट का टोटल टाइम नहीं पता चला इज दैट क्लियर टू एवरीबॉडी
Yes, ma'am.
आंचल समझ आया नहीं आया जहाँ ऐसे ही लग रहा है कि थोड़ा थोड़ा आया
नहीं मैम आ गया.
चलो next is draw the network diagram I have drawn the network diagram now next is to find the early finish early start late finish late start you can see some formulas on the screen you need if you know early start and duration you can calculate the early finish and if you know late finish and minus duration you can calculate the late start and to find the float you need to calculate the late start minus early start आपको इनको formulas को याद रखने की you need not to remember these formulas what is the difference between them I will be showing you on the slide as well as on the board how to calculate the path in the diagrammatic representation and that is very easy so you can see on the screen here there is one example given task duration and predecessor a has duration 2 b has duration 2 c has duration 1 d has duration 3 e has 1 f has 3 and g has 2 and they have specified the uh, predecessors also सबको predecessor पता चल गए is everybody clear with the predecessor predecessor means the previous activity b के से पहले क्या है a है can you draw the network diagram for this problem everybody in the class can you draw the network diagram for this problem can you hear me
Yes, ma'am.
Yes, ma'am.
can you draw this network diagram for this problem तो बनाओ फिर फटाफट
ma'am.
draw this network diagram only then I'll move forward and you can see whether you have made the correct diagram or not it will take 1 minute only are you drawing or not
Yes, ma'am.
ओके ड्रॉ करो आपको पता चल जाएगा आपको नेटवर्क डायग्राम बनानी आई कि नहीं आई आई एम गिविंग यू 1 मिनट ड्रॉ द नेटवर्क डायग्राम शोन ऑन द स्लाइड Giving you 1 more minute. I hope everybody has drawn this network diagram.
Yes, ma'am.
So should I move to that very network? ऐसी कुछ diagram है. Just see A, B, C, D are in parallel, and after that there is F, E, and from the F and E we are moving towards G. Is that clear to everybody? Can you see on the screen? And here is a duration also. A has 2, B has 2, F has 3 duration, C has 1, and D has 3, E has 1, G has 2. आपकी डायग्राम ऐसी है? नेटवर्क डायग्राम क्लास
Ma'am, screen is not visible.
Yes,
cannot
ma'am.
see screen. Let me see what is the problem. See the diagram. Network diagram. A has 2 duration, B has 2, F has 3, C has 1, D has 3, E has 1, G has 2. And see the dependencies. B, C, D, both three of them are dependent upon A. And this E is dependent upon C and D. This G is dependent on F and E. ऐसा ही बना आपका network diagram.
Yes,
Can
ma'am.
you
Yes,
see
ma'am.
on the
Yes,
screen?
ma'am.
So
Yes.
you can draw the box in this form. आप किसी एक्टिविटी को उसके आगे बॉक्स ड्रॉ कर लो, like shown in the PPT here. This way you can draw the box, because we need to calculate early start, early finish, latest start, latest finish, and F. F is the float, dr the duration, id is the activity. I am repeating again, id is the activity. This id means activity a hai, b hai, c hai, and this is early start, early finish, latest start, latest finish. अभी तक आपको किसी activity, what you have right now in the activity is only the duration. You need to know only the duration. So you can see here you have only duration. A has 2, C has 1, B has 2, F has 3, G has 2, D has 3, and E has 1. So we have ID and duration. Why? But we need to calculate early start, early finish, latest start, latest finish. Should I move further? Is that clear to everybody? So you can see here A is the first activity. So early start क्या होगा उसका? A का A पहली activity है, that means A will start from 0. ठीक है, 10 बजे क्लास स्टार्ट हो रही है, will say it is taking 2 hours, that means it is from 0. So we have 0 here, and early finish क्या है? 2 hours की क्लास है, तो सबसे early finish possible क्या है? It will be 2. The duration for that activities is 2. Is that clear to everybody? Early start क्या होगा इसका? A का? It will be 0. And what will be the early finish? It will be 2, because the activity is taking 2 hours or 2 weeks or anything related to. We are not going with the units. 0 से start हो रही है और 2 ले रही. Now for B has the predecessor, which activity? A. So B we can only start if A has completed, and B will take 2 days or 2 hours to complete. 2 hours to complete, suppose. So B can early start at 2. B कब start हो सकती है? B activity suppose B मतलब 12 बजे आपका next lecture है, तो maximum early start क्या हो सकता है? 12 बजे से हो सकता है, 11 बजे तो start होगा नहीं. Is that clear to everybody? There will not be a parallel lecture. मेरा और किसी का parallel lecture तो होगा नहीं. मैं जब 12 बजे खत्म करूंगी तभी दूसरे का lecture होगा ना. So in this way it will have early start of 2 and early finish 4. 2 plus 2, 4. Is that clear to everybody in the class? Say yes or no. Only then I will move forward.
Yes, ma'am.
Early start, early finish किसी को? Anchal. There are so many students. Mitesh, Anchal, Gagandeep, Abhinav. Nobody is speaking. किसी को समझ नहीं आ रहा? Or you people are
आ रहा है मैम.
आ रहा है?
Yes,
So
ma'am.
you can see here, you 0 से start हुआ, it is taking duration of 2 hours. So the early finish is 2. 2 से start हुआ, just because it has finished at 2, it will start from the 2 and will finish at 4, just because duration is 2. Now it is finishing at 4 and it will be starting at 4 and completing at 7. In the same way, it will be starting from 2, it will be starting from 2. It will be completing at 3, it will be completing at 5, just because 2 plus 3, 5, 2 plus 1, 3, 2 plus 2, 4. Now, see in this case, this E activity is dependent upon D and C. This E activity is dependent upon C and D. आपकी क्लास में ऐसे कुछ स्टूडेंट्स हैं that are attending some of the students are attending C any other lecture, and some of the students are attending D some other lecture. But after completion of their lectures, they will be joining a lecture that will be combined lecture, that is E. So now it is finishing at 3, this is finishing at 5. So when E will start, एक 3 पे खत्म हो रही है क्लास, एक 5 पे खत्म होगी, तो नेक्स्ट क्लास सारी कंबाइंड कब लग सकती है? 5 में ही लग सकती है ना, जब मैक्सिमम वाला कंप्लीट होगा. Is that clear to everybody?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So it will be starting at 5. It will not. Why it will not be starting at 3? Because this activity will not be completed till 3. हमने 3 और 5 में 3 क्यों नहीं लिया? 3 लेंगे अगर, तो ये एक्टिविटी कंप्लीट नहीं होगी, और ये एक्टिविटी कंप्लीट नहीं हुई है, तो इसलिए ये वाली it will not move further. This E will cannot happen if D has not been completed. In this way, we have to take the maximum value here. Now this 5 will be here. This duration is 1. So that next activity will be 6. this will complete at 6. In this way we have a 7 and 6. From the 7 and 6 we'll choose 7. So from 7 plus 2 we'll have 9. 9 as the total duration of these activities. The finish time of all of this project will be 9 days. Is that clear to everybody?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So now we are done with early start, early finish. हमने सबका early start, early finish. We have calculated the
ma'am.
early start, early finish, early start, early finish. Now we need to calculate the late start and late finish. This 0, 2, 2, 4, 4, 7 moving forward is called forward pass. Moving forward from A to G is called forward pass. And at G we analyze that we can complete the project with 9 days or 9 weeks or 9 hours or anything related to that. Here they have taken 9 days. Now this is a total time, the early finish time. What is the early finish time will be the latest finish time. Okay, so what is next in the figure here? You can see this. Just see this diagram here. अभी यहाँ पे जो 9 है, this 9, keep this 9 here in the downward. Latest finish पे आप 9 लिख लो. 9 लिख लिया. From the 9 we need to see the duration. We need to see that duration is 2. So minus 2, 9 minus 2, what will be the latest finish, latest start? This latest start will be 7. 9 minus 2, 7. Now we need to move backward. हमने ऐसे जाना है, पीछे move करना है. पहले हम क्या जा रहे थे? We were moving forward. Now we are moving backward in this way. यहाँ से हमने यहाँ जाना है. So you can see from 9 minus 2, what will be the latest start? 7. For which activity? G activity. For E activity, place this 7 here at this 7. From 7 minus 1, 6. Place this 6 here. So the E activity will have latest start 6. Is that clear to everybody? जो ये 7 आया था, ये दोनों तरफ 7 आ जाएगा. Which 7? This latest finish 7. Okay, are you getting what I'm saying in the backward pass?
Yes, ma'am.
Yes, ma'am. Yes,
This
ma'am.
9 is the duration. आपको ऐसे ही 9 जो नीचे लेके आ जाना. ठीक है, 9 is the maximum time. From the 9 we are subtracting the duration, that is 2, and it will be 7. That will be the latest start. From this 7 we are keeping this 7 because this G पे कौन predecessor कौन से हैं? F and E. So this will be 7 here. This 7 and 7. Minus, you need to subtract the duration. So you can see 7 minus 3, 4 here. 7 minus 1, 6 here. Amin, Deep, is there any issue?
Yes, ma'am.
Yeah.
Hello.
Yeah. I'm
Yes, ma'am. मैम
listening.
ਜਿਹੜਾ backward pass समझाया ना वो एक बार repeat कर दो वो समझ नहीं आया.
Should I speak in English or Punjabi or?
मैम जिਵੇਂ मर्जी.
Okay, I am repeating.
Yeah, मैम जिਵੇਂ मर्जी.
Forward
Yes.
समझ आ गया? Is that forward is clear to everybody?
Yes, ma'am.
Okay. हम यहाँ पे आगे पिछले वाली डायग्राम पे जा रही हूँ मैं, यहाँ तक 9 यहाँ आ गया. इस 9 को आप यहाँ लेके आओ जहाँ पे मैंने अपना कर्सर रखा हो. 9 that will be called as latest finish. We are moving backward now. 9 यहाँ पे आ गया. ड्यूरेशन कितना था? 2 था. तो 2 माइनस कर दिया तो स्टार्ट क्या हुआ? लेटेस्ट स्टार्ट 7 ईयर. यहाँ 7 आ गया. ठीक है, 7. यहाँ पे 7 आया. दैट मीन्स लेटेस्ट स्टार्ट इज 7. दैट मीन्स latest finish will be 7 here and 7 here in both the cases because these are the predecessor of this activity. So I am placing 7 here. ਇੱਥੇ भी 7 आ जाएगा इस box भी, and here it will be also 7. You can see in the backward pass 7 and 7. After 7, ਇੱਥੇ भी 7 आ ਜਾਂਦਾ, ਇੱਥੇ भी 7 है. Now what we are doing is we are to minus the duration. 7 minus 3, 4. 7 minus 1, 6. So 6 will be placed in this box, Uh, 7 minus 1, 6 will be here, and 7 minus 3, 4 will be here. So you can see on the backward pass, 4 will be here and 6 will be here. That is the backward pass. Green wala jada. 4, 6. Now, further moving, this uh, this 6 will now be copied to 6 here and 6 here, just because this E has two predecessors C and D. So 6 will be the latest finish, and latest finish in the C will be 6. 6 minus 1, 5. 6 minus 3, 3. Is that clear to everybody? So you
Yes.
can see, in this way we have calculated the latest finish 253. Now which one to choose from 253? You need to choose the minimum. 253 में आपको minimum choose करना है. You are choosing this 2. 2 minus 2 duration is 2. What will be the latest start? 0. So in case of forward pass, you need to choose from 4, 3, 5. You need to choose the maximum. In case of backward pass, you need to choose the minimum. So 2, 5 और 3 में from the 2, 5, 3 you need to choose the minimum in the backward pass. But in case of forward pass, from 4, 3 and 5 you need to choose the maximum. I hope you are clear with the forward and backward pass now.
Yes, ma'am.
कितनी
Yes, ma'am.
डायग्राम बन जाएगी सबकी? Is that clear to everybody? Is that clear to everybody in the
Yes, ma'am.
class?
Yes,
Yes,
ma'am.
ma'am.
Deva, Gagan, Madhav, Abhishek,
Yes,
Abhinav,
ma'am.
Kartik,
Yes, ma'am.
Aditya,
Yes, ma'am. It is clear.
जिनका नाम नहीं बोला
Yes,
वो भूल
sir.
गई. So after doing this, what you need to find is you need to find the slack time. Slack time. This red will define the slack time. अभी slack time क्या है? You need to minus. This slack time is also called float. So minus ls, this ls minus es, ls minus es. ये तीन कॉलम देखो. ग्रीन में से ये ग्रे माइनस करना है. ls latest start minus early start, you will get f. That is float. In this case, 0 minus 0, 0 float. 2 minus 2, 0 float. 4 minus 4, 0 float. 7 minus 7, 0 float. 6 minus 5, 1 float. 3 minus 2, 1 float. 5 minus 2, 3 float. So you have calculated the float in every column. Here 0, 0, 0, 0, 1, 1, 3. जिन activities का float 0 आता है, that will form the critical path. So the activities A, B, F, G is forming the critical path. I hope it is clear to everybody now. Or should I repeat it? Is that clear to everybody? The critical path calculation and the float calculation.
Yes, ma'am.
Can we do the example
Yes.
shown on the board now?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
So I'm doing that which is shown on the board here, so that you get an idea of your problem, because you need to do with me. आपने भी मेरे साथ साथ करना है. It will be clear, more clear to you. Should I rub this? Have you written or drawn these things on your copy or anything? But you have taken to note
Yes,
your
ma'am.
points. So we have activity A. I'm drawing the boxes here, small boxes. A. Next is B and C. Next is D, E, and F. छोटा कर रही हूँ because it will not be completed in the space because board छोटा है. D, E, E, and here it is F. And from E and D we have D and E we have G. This G. And from this G and F we have H. I'm drawing here. Just because of the space problem, I'm drawing. This is the last activity, that is H. We know that duration of A is 3. मैंने यहाँ पे duration लिख दी 3. B has a duration of 4. C has a duration of 2. D has a duration of 5. E has a duration of 1. F has a duration of 2. And this G has a duration of 4. And H has a duration of 3. Can you draw in this form what I have drawn? Is that clear to everybody? Board पे जो लिखा है, is that clear to everybody now? The dependencies.
Yes, ma'am.
Here we have not drawn the dependency. Is that clear to everybody now? अभी हमें पता क्या करना है? We need to find out the early start, early finish, latest start, latest finish. For this case, this A, the early start is 0 and early finish is 3. For this case, the early start is 3 and early finish is 7. For this, early start is 3, early finish will be 5. For this case, early start is 7, early finish is 12. In this case, early start is, we cannot find the early start here. We need to find the early start. For this case, the early start is, what is the early start in that case? It will be 5. 5, because it is early finish is 5. So early start of E will be 5, early start of F will be 5. It is taking 1, so early finish is 6, and here early finish is 7. So is that clear to everybody? So it will be having 12, 6. What will be the number here? As D is dependent upon the precedence, the decers E and D. 12. And what is the early finish?
16.
16. Good. Is that clear to everybody?
Yes, ma'am.
What about this? It will have
16.
this will have 16 as 16. Because ये कहाँ से आ रही है? This is coming from this side. Because of the space problem. So if we have 16 and early finish will be 19. This is your finish. And this is your start. So we are done with early start, early finish, early start, early finish, early start, early finish, early finish, early start, early finish, early start, early finish, early start, early finish. सबका ड्रॉ हो गया इतना डायग्राम. Now this is called forward part. We are moving forward. So that is why we have taken 12 here. We have taken a maximum. 12 और 13 हमने यहाँ maximum लिया. Now 19 is here. What we need to do is write 19 here. This is the last activity. Write 19 here. From 19 minus 3, what will be the finish 16. Is that clear to everybody? 19, right? Early finish as late finish 19 here. Minus 3. This is the duration, and what will be the late start? Late start will be 16. We are now moving backward. हम move कर रहे हैं backward. Now in that case, in the case of this G, 16 है, 16 minus 4, 12. In case of 7, 2, this is dependent on this activity. So 16 will be here 16. 16 minus 2, it will be 14. It will be having 12. It will be having 12. Here it will be 7. 12 minus 5, 7. 12 minus 1, it will be 11. Is that clear to everybody? We need to find the backward way. From here 19, 19. 19 minus 3, this box will have. So this has 16, 16, 16, 16 minus 4, 12. So we have 12 here. This 12 will be written here and here because this G is dependent upon this and this. So 12 will be here, 12 will be here. 12 minus 1, 11. 12 minus 5, 7. In the same way, this is the previous activity of actually is having 3 decimal F. So 16 will be written here. 16 minus 2, 14. So this activity from 11 and 14, what we need to choose from 11 and 14.
11.
11. 11 will be there. From 11
11
minus 2,
2.
9.
9.
Now this will have 7. 7 from this 7, 7, 7 minus 4, 3. Is that clear to everybody? From 3 and 9, what we need to do? The minimum. Which will be the minimum? 3.
3.
And from 3 minus 3, it will be 0.
0.
So you can see this path has float 0. This path. जो मैंने डाल किया. 0 minus 0, 0. 3 minus 3, 0. 7 minus 7, 0. 12 minus 12, 0. 16 minus 16, 0. So this will be the critical path. Why not this will be the critical path? Because it has flow. 14 minus 5, 9. 9 minus 3, 6.
6.
11 minus 5.
6.
So this cannot be the path. This cannot be the path. Is that clear to everybody?
Yes, ma'am.
कि बच्चा बोल रहा है आंचल. Is there anybody else? आंचल को तो समझ आ गई. और कोई है क्लास में?
Yes, ma'am.
Is that clear to everybody?
Yes, ma'am.
And we have a poll here that may not be related to this topic, but project scheduling के बारे में हो गया. So I'm launching here. Dash in a project refers to roadmap of all activities to be done with specified order and within time slot allotted for each activity. Should it be project processing or project scheduling? Next is Dash is a method of analyzing the task involved in completing a given project, especially the time needed to complete each task and to identify the minimum time required to complete the total project. So whether it is PERT or CRF, answer these questions. only few students have answered these questions. Kindly answer these questions. Your response is recorded and your evaluation is based on these polls. Your class evaluation is based on these polls. Kindly answer these questions. I'm ending poll here. So first question answer is project scheduling. In a project, refers to roadmap of all activities to be done with a specified order and within time slot allotted to each activity. Other one is uh, dash is a method. So that method is a third method of analyzing the task involved in completing a given project, especially the time needed to complete each task and to identify the minimum time needed to complete the total project. So these were the answer to these questions. There is another poll. Kindly answer these questions. Still, some students are pending. Kindly answer these questions. The shortest time in which the activity can be completed, whether it's optimistic time, pessimistic time, or estimated time. Next is the maximum possible time required to accomplish a task, assuming everything goes wrong. What is it? Whether it's optimistic, pessimistic, or estimated. I'm ending tool. So the answer to this question is the shortest time in which the activity can be completed is optimistic time. The maximum possible time required to accomplish a task, assuming everything goes wrong, is pessimistic time. So these are the answer to these questions. Moving forward, next topic is and this is a constructive cost constructive model, most widely used for calculating the cost and effort and schedule of software product. It is basically defined in terms of three different models. It has three different steps, like basic model is there, COCOMO basic. I'm repeating, this is cost constructive model, most widely used for software estimation. Which kind of estimation we are talking about? We are talking about, let me do this full screen. It has a basic model, intermediate model, and detailed model. But we can calculate this using this COCOMO model is basically, and what will be the input this model and what will be the output we will be getting from this model. We will be getting effort and time. So from the effort we mean how many employees we will hire and how many for how many days or how many months, and what will be the time duration. We can calculate people and time because they will form the cost of that very project. किसी भी प्रोजेक्ट की कॉस्ट किससे पता चल गया? डेवलपमेंट टाइम वी रिक्वायर टू कंप्लीट दैट प्रोजेक्ट. कितने डेज के लिए हमें हमें वो बंदे हायर करने पड़ेंगे, एम्प्लॉयज वी नीड टू हायर, द सॉफ्टवेयर डेवलपर्स वी नीड टू हायर, and the time, the month it will take to complete that very project. That is the concern. So COCOMO is defined in terms of three different model: basic model, intermediate model, detailed model. The more complex model account for more factors that influence software projects and make more accurate estimates. The first model, that is the development mode, that is the development mode, the simple mode, that basic model consists of three types of further modes, that is organic mode, semi-detached mode, and embedded mode. Three modes are there: organic, semi-detached, and embedded. Organic mode is a project. Organic mode is the mode in which the project is developed in a familiar, stable environment and the product is similar to the previously developed products. We can apply this organic mode to those projects that we have developed earlier. Previously developed products पे हम apply कर सकते हैं. Like we are developing university management system, and earlier we have developed the university management system. हमने पहले भी बनाया हुआ है. For that kind of things, we can move towards the organic mode for calculation of effort and time. Now, semi-detached mode. The project's characteristics are intermediate between organic and embedded. So, and embedded mode is totally, the project is characterized by tight, inflexible constraints and interface requirement. This type of embedded mode is the one in which tight, inflexible constraints are there and interface requirements are also tight and inflexible. And that that project requires a great innovation. कोई नया project है, innovative है, we need to follow the embedded mode. If there is a project we have already done and we are developing same kind of project, we can have that organic mode. And if that project is something mixed between the organic and embedded we can have semi-detached mode. So first what we need to see while finding the effort and time is we need to see whether the mode is of the project is organic, whether it is embedded or whether it is semi-detached. We need to find the development mode. What we need to do is next, for finding the effort and time we need one thing, that is the input. What input is required to find that mode, this effort and time? How we can calculate the effort and time? For finding the effort and time we should have some input from the project, and that is called KLOC, line of code metric. We have not studied in detail about it, line of code. K means 1000. Suppose your project has 32,000 line of code. You will write 32 KLOC. If your project has 50,000 lines of code, you will write as 50 LOC. And this will be the input to the organic, embedded and semi-detached for calculation of effort and time. So here you can see on the screen they have defined some parameters. For organic they have A, B, C, D. What does this A, B, B, C, B and D, B means? For calculating the effort, in the COCOMO model, E defines the effort and D defines the development time. For finding E, you can have A, B, K, L, O, C into B, P. From K, suppose I have a software, I am developing some project and it has 32 LOC. So it will be 32. A, B is already given, B, B is already given. It differ from mode, whether you are taking organic, semi-detached or third one is embedded. So you can have organic, semi-detached and embedded. For everything, every organic, semi-detached and embedded, this AB and value of this AB and BB will differ, and this CB and DB will differ. That is shown here in the diagram here. For organic, AB will have value 2.4. For semi-detached, it will have a 3.0. For embedded, it will have 3.6. Suppose my project that I am going to develop to calculate the effort, मैंने effort calculate करनी है. My project is of organic type or my project is of semi-detached type. If my project is of organic type, this AB value will be 2.4 into 32 and BB will be 1.05. That is shown on the PPT here. So the effort will be 2.4 into 32 raised to power 1.05. This will be the effort required. And if we want to find the development time, the formula for development time is given on the PPT here. Development time is CB and DB. E, आपने यहाँ से E calculate किया, you have calculated the E. Now E is CB. E is equal to CB and DB. So in case of organic, it will be 2.5 E and DB will be 0.38 in the case of organic projects. This is for the organic project. This will be the effort. This will be the duration. From the effort, whatever will be the output, the unit will be person months. Person month mean number of employees for how many months. 30 employees for 2 months. Such kind of answer will be there. And duration means the number of months. Only the number of months. Is that clear to everybody? Are you listening? CSE 5th.
Yes, ma'am.
Is that clear to everybody?
Yes, ma'am.
Yes,
How
Yes,
can
ma'am.
we calculate the
Yes,
effort
ma'am.
and duration for organic? Here I'm showing only the example of organic. So for any type of category of model like organic hai, semi-detached hai, embedded, we need four things. This AB, BB, CB, DB and KLOC. हमें अपने प्रोजेक्ट का KLOC पता होना चाहिए and we should know the type of that सॉफ्ट प्रोजेक्ट कि ऑर्गेनिक है, एम्बेडेड है और जहाँ फिर सेमी डिटैच्ड है. एंड वी नीड टू remember these formulas. The value of AB 2.4, value of BB 1.05, value of CB 2.5. We need to remember this table for doing numericals. I hope this is clear to everybody.
yes, ma'am.
So what is the difference between the effort and duration is only you can calculate the duration only if you have calculated the effort. After calculating the duration, after calculating the effort, you can calculate the duration because for finding the duration we need to have identified, we need to calculate the effort first. Effort is number of persons, I am repeating, number of persons and how many months they will be employed for completing that particular project. So this is basic Como equation. These are the basic Como equations. So P is equal to total number of persons required to complete the project. That number of persons required to complete the project. P will be given by E and D. E is the effort and D is the days. So the number of persons will be there because here we are calculating person months, here we are calculating only months and P is equal to E by D. So P is E क्या है PM and what is this M cancels, so answer will be P, persons. Number of person required to complete the project. What are the merits? Good for quick early rough order of estimates. This is the only the estimate. हमने exact figure नहीं निकाले. We are calculating the estimate कि project को complete होने में कितना खर्चा आएगा बनाने में. The limitation is accuracy is limited. Does not consider certain factors like they are not considering any other factor. अगर programmer expert होगा, if the programmer is expert, he may be completing this, taking this into 18 LOC suppose. वो 32,000 LOC की बजाय भी प्रोग्रामर उसको 12,000 LOC में भी कंप्लीट कर सकते हैं लाइंस ऑफ कोड में. If all the developers in developing that project are experienced, they may take lesser number of codes. It is totally dependent on person to person or the programmer to programmer. मैं कोड 100 लाइन में लिखूंगी, कोई कोड उसको 1200 लाइंस में लिख सकता है, 1500 लाइंस में लिख सकता है. So these are the, we can say, the demerits kind of thing because it is not considering hardware constraint, they are not considering personal quality, they are not considering experience, they are not considering tools. The basic Como model. Suppose this is one of the example here. Suppose consider a software project using semi-detached mode. So उसने बता दिया है कि mode is semi-detached and with 30,000 lines of code. We will obtain estimation of the project as E is equal to AB, KLOC, BB. So for semi-detached, we can have AB as 3.0 and BB as 1.12. So you can see here AB as 3.0. KLOC की जगह पे 30 आ गया and for BB we have 1.12. So it comes out to be 135 person month the effort. For calculating development time, what we need to do is development formula लगा देंगे, but that will be 2.5 into 1.3 raised to power 0.35, that is 14 months. The duration will be 14 months. Always remember this is the estimated. We are calculating the estimate of effort, duration, time. Is that clear to everybody?
Yes, ma'am.
So the person estimation will be 135 divided by 14. The person, that number of person required is 10. For how many days? 14 days. So the effort will be this way. So अगर आप 10 को 14 से multiply करोगे तो it will be 140 and it comes out to be nearly 135, nearly 140. So this was given as approximate value, 10% approximate value. I hope this is clear to everybody, this COCOMO model. Basic COCOMO. Now we're moving towards intermediate COCOMO. Intermediate COCOMO computes software development effort as a function of program size and a set of cost drivers. So it is not only considering those lines of code, it is also considering functions of the effort as a function of program size. Effort is part of program size, and cost drivers also included that are totally assessed based on product, hardware, personal and project attributes. मतलब ये बोल दिया गया that it is not the effort is not totally dependent on the lines of code. There may be some other factors. So they have given those factors based on product, hardware, personal and project attributes. So and they have given rating to 15 attributes, and rating is given from very low to extra high. What does this mean? This means 15 attributes, or we can say the characteristics based on experience, personal information, and we can say hardware, etc. And every attribute, if I am considering the first attribute, it is having a scale from very low to extra high. Very low to extra high, and that defines the effort multiplier factor. Effort multiplier factor, and that is called EEF, that is effort adjustment factor. If any attribute is there with the value 1, whether that attribute is very low in that project or very high. If it is having a very low, it will have a 1 value. If it has a very extra high, it will can have a 6 value kind of concept is there in that for finding the adjustment factor. So you can see on the screen the cost drivers. Product attributes, it has 3 cost driver: required reliability, database size, product complexity. Computer attributes include execution time constraint, main storage constraint, virtual machine volatility, computer turnaround time. Personal attribute include analyst capability, programmer capability, application experience, virtual machine experience, program language experience. And project attributes include use of modern programming practice, use of software tools, required development schedule. So you can see these are 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Then there will be more 2. So they are considering up to 11. For calculating in the case of intermediate COCOMO, the equation is this like this. आपने lines of code तो पता ही है, and there will be other factor called effort adjustment factor. So this will be the old basic COCOMO for calculating the E. E stand for effort, and this is the effort adjustment factor. So you can see here, the merits here are this can be applied to almost entire software for easy and rough cost estimation. Can be applied at the software product component level, and it has a limitations like many components are difficult to estimate. So estimation issues in case of this intermediate COCOMO is historical data, accuracy, estimation techniques may not be proper, automation may not be apt to that level, and there is need to improve the estimate. So this was all about intermediate COCOMO, and that is another COCOMO model, that is a basic COCOMO. We need not to study this advanced COCOMO, that is not in your syllabus. Even the intermediate is hardly comes in paper. Usually this basic model comes in your paper, for which we have discussed the numerical here. Suppose now what I am doing is I am giving you one example here, but you need to find the write down. Consider a software project that is using embedded mode with 32, not 32, 40,000 lines of code. Embedded है project. Project is embedded, and it has 40,000 lines of code. Calculate the effort and time. Kindly do it fast. Calculate the effort and time for that very mode. Find the effort and time. With that, I am launching one poll here, and kindly answer these questions. Only 6 students have answered these questions. Kindly answer these questions as well as answer to the numerical that I have given you. Embedded mode with 40,000 lines of code, you need to calculate the effort and time. First is dash may added to start an activity before the predecessor activity and is completed in network diagram. Whether it's a lead or lag, dash is the path with the least amount of float or slack time. Critical path or simple path. Kindly answer these questions. Your response is recorded. You will be evaluated in the class based on the poll response.
Ma'am, answer for numerical is 301.
301. Anybody
Yes,
else?
ma'am.
So we have chosen this 2.8 into 40 raised to power 1/20. Am I right? Answer will be 234, I guess.
मैम 2.8 होगा या 3.6 होगा?
It will be 2.8 into 40 raised to power 1.20 because the mode is embedded.
मैम बट एम्बेडेड के लिए मैम
मैम वो बेसिक के लिए
3.6 है.
Oh, okay. Sorry, I am
वहाँ पे
looking at this
3.6
intermediate
Yes,
thing.
ma'am.
Sorry for that.
मैम 301 आना है.
It will be 3.6. It will be, let me see, it will be
3.6
301.
40 raised to power 1.20 into 3.6. It is 301, yes. Answer is 301.1. Is that clear to everybody?
Yes, ma'am.
yes ma'am.
So you can calculate the effort. Now calculate the development time.
Yes.
Have you calculated the development time? So answer to these questions are lead may be added to start an activity before the predecessor activity is completed in network diagram. Other one is critical path is the path with the least amount of float or slack time. So these are the answer to these questions.
Ma'am, development time is 15.5.
Yeah, development time is 15.5 and we have effort as 301. Now calculate the persons. That will be 301 divided by 15.5. That comes out to be 19.4. So the number of person required will be nearly 19 approximately. Is that clear to everybody?
Yes, ma'am.
It comes out to be 301 divided by 15.5. The number of persons required will be 19.4, approximately 19, or we can say approximately 20. As it is below 5, so it will be approximately
Yes,
90.
ma'am.
So next there is one another poll related to the today's topic, and we are concluding the today's topic. If you have any issues, now this is the syllabus of your first sessional. Part 1 and part 2 is completed today. We are done with the part 2. Numericals based on these topics related to this critical path and that COCOMO model will be asked in your sessional. So practice, practice, practice. There is another poll related to this topic where answer these questions. All are required to answer these questions. First is COCOMO model, that is whether it's a cost constructive model or constructive model. Next is project is developed in a familiar, stable environment, and the product is similar to previously developed products. The product is relatively small and requires little innovation. What is whether it's an organic mode or semi-detached mode? Answer these questions. Still, a lot of students have not answered these questions. Ending poll here. Cost constructive model, COCOMO model, and other one is subject is well been familiar. For that, the answer is organic mode. We know that. So this was all about the part 1 and 2. If you have any queries related to these, you can ask me now. We have 4 to 5 minutes. Anything related to part 1 and part 2, anything you have not attended, any class you have not attended, or any resource, any material you are not getting, if you have any issues related to that, you can ask me in this class. I'll provide you accordingly on the ERP, on the WhatsApp, as well as will upload these videos on the YouTube channel. No problem at all. If a problem will be given in the paper, can you answer related to this project scheduling? Any problem related to this calculation of critical path? Lavpreet Singh, Jagmeet Singh, what is the problem?
मैम सैम्पल क्वेश्चन सेंड कर सकते हैं आप इनके?
Sample? Why you
यस मैम,
need a sample paper?
आइडिया हो जाए
There
पेपर
is
में क्वेश्चंस
there
कैसे
is
हैं.
so many okay, I'll send you 1 to 2 examples related to this topic, project scheduling and calculation of critical path.
यस यस मैम, थैंक यू मैम.
Any other issue? anything that you are not able to understand, or you're not aware of, or the lecture you have not attended, and you have not the material to that, access to that material. Nothing, you know everything. सबको सब सॉफ्टवेयर इंजीनियरिंग का पता है, that everybody can do. Let me see who are there in this participant list. Akriti, Anchal Mittal, Abhinav, Abhishek, Aditya, Amanat Veer, Amin, Amisha has recently joined. Abhishek, is everything clear to you? ये म्यूट लगा के कहीं ये हुए अभिषेक. Abhishek. So you can see the seriousness of your class also. Birendra Joshi.
Yes, ma'am.
Birendra Joshi
Yes,
is
ma'am.
not also attend. Are you there, Birendra?
Yes,
Okay.
ma'am.
Birendra, is everything clear to you from the part 1 and part 2? Or is there any issue? You are
No,
not
ma'am.
able to
Everything.
understand anything in software engineering?
Nothing is there, ma'am.
Everything is clear. Okay.
Yes, ma'am.
Deepak Kumar. Roll number 10, 210. Dilip Kumar Singh. Dilip Kumar Singh, are you there or should I remove you from the class?
Yes, ma'am. Hello, ma'am.
Hello. So,
Hello,
सब clear है?
ma'am.
Is that everything clear to you from part 1 and part 2? I hope I have covered all the topics. Even then, if you have any issues, you can message me or WhatsApp me. Kindly message or WhatsApp me between 9 to 5. There are some students who used to call at 10, 11, 10:30. And there are some students who are asking questions related to this joining. Kindly, if you are removed from or you are denied from this class, kindly contact the Jinder ma'am for that, or HOD sir. That ma'am has not joined us in the class. Okay, students, thank you very much. I am ending this class here.
Thank you, ma'am.